Hello and welcome back to the channel. In today's video, we are going to build this interactive periodic table of the elements together from scratch in Python. So I am super excited to bring you guys this project. It touches on a ton of different Python concepts, and it really breaks down into three pretty clean sections that will be as chapters below. So if this video ends up a little bit longer than you can do in one sitting, you might just want to do one section at a time. But basically, we're going to start by getting the data using the Pandas module and grabbing the table from a Wikipedia table. So that we don't have to manually type in all of the information for the periodic table of the elements. And then the second section is going to be taking the CSV that we saved from that Wikipedia table, and we're actually going to kind of clean it up and put it in a format that we want to use for displaying on the screen and interacting with. So there's going to be some cleaning of data with the CSV module and some Python elements. And then the last module will be putting together the actual interactive front-end graphical user interface that we'll do in Pygame. You could do it in Kivy or Kinter or whatever your preferred kind of graphical user interface is, but I'm going to use Pygame because I'm the most comfortable with it, and I also think it gives you a lot of flexibility on the design very quickly. So this is a super cool project. It really does break up into those three sections, and it touches on a lot of the things about Python that are so cool. So I really am looking forward to getting into this tutorial with you guys. Really quickly, I just want to say thank you, everybody. I do have a son now. I was kind of inactive on the channel for the last 2 weeks or so. I published some pre-recorded videos, and I got a lot of really nice comments and support and everything. So thank you, everybody, for that. Massive thank you to my Patreon supporters, of course, because during kind of this hectic, busy time, that support goes even further. So thank you so much. And without any further ado, let's dive right into the tutorial. All right, so the first step in this project is going to be getting the data for our periodic table. And I'm also kind of pleased to say it's sort of the easiest. If you're familiar with the Pandas module, then this may seem a little bit basic for you. But if you're not familiar with the Pandas module, just import it. And the most common way it gets abbreviated is as PD. You may need to do pip install pandas to just get the module installed if you don't already have it. But then the other thing you might need to do, I don't because it's already installed, you might need to do pip install lxml. A lot of the times these two go together depending on what data you're pulling in using Pandas. And then really the next most important part is just the URL where the table that you want to kind of steal lives. And for me, it's just this Wikipedia page that is wikipedia.org/wiki/periodic table. So I'm going to copy that URL. And the table I want is this one. It's got the element names, it's got the atomic number, it's got the weight, and it's got the abbreviation. So we're going to take that table if we can. And so what we do is we create a URL variable, and we put that URL right in here. And we're going to use that in the kind of read HTML section of Pandas. So what we'll do is we'll get all the tables that are in that article. So we'll do tables equals pd.read_HTML of that URL. Okay, and so what this is going to do, it's going to give us all of the tables that are on that Wikipedia article. And there is something really nice that you can do in here typically, which is define some attributes. So if it had like an ID, you could say, I want the tables that have the ID of like my table. And you may be asking, if you're a real unfamiliar with Pandas, how would I know those ID things? Well, you can go on any HTML page on the internet, and you can right-click an element and do inspect. And what you need to do is you need to find inspect. You would scroll up until you find table like this, and some Wikipedia tables will have an ID, like a defined name, where you can look just for that table. This one actually doesn't. It's just a wiki table. So what we're going to do is not the most elegant thing, but this isn't a deep dive into a Pandas tutorial. We're going to grab all of the tables that are on that page, and then we're just going to kind of look until we find ours, okay? So we're not going to do this attributes thing here. I just want to let you know that is a way to sort more data using pandas. But so what we'll do, just so we know what we're getting, is we'll print the length of tables now that we're reading it in. And let's just run this, okay, and just see what we have here. So we're running get data. And it shows that I have 29 tables in pandas, okay, from that article. But again, going back to my web page, you can kind of look at the page. And this is just an image here in the top right. And then this is clearly a table. And then this is the next table on the page. And if I keep scrolling, you'll see there are a ton of tables in this Wikipedia article. So what I'm going to do is kind of hypothesize that it's one of the first tables. And so I'll make this variable target data. And I'm going to say it equals tables of some index. Okay, so let's take a look at what tables 0 is. All right, let's go ahead and print target data and see what that gives me if I grab the 0 index of my tables. All right. And we can see we get that that 0 through 13 part of a series on the blah, 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 blah. And if we come back to our web page and we look at it, we see that we've got this part of a series on the periodic table, blah, blah, blah. Okay, so let's check out what the next table is. All right, tables 1. And bam. Okay, so it looks a little funny, but you can see we have these noble gases, helium, blah, blah, blah. And there's this weird formatting going on where we can't really see the data that we have. So I know, because I've already done this project, that that is the correct table, but a couple things you'd want to do to make sure you're seeing it appropriately. We're just going to do two pandas things real quick. We're going to do pandas.set option, and then this one will be display.max_columns. And I'm just going to say 35 because I don't remember how many we need. And then pd.set option, and I'm going to do display.max rows, and I think 35 is going to be fine here. And all I'm doing is I'm saying instead of these 3 dots that I'm getting down here in this console window, I want to see all of the data that I'm pulling in when I print it out. So now if I run this, get data, okay, now you're going to see, great, I have this. It's still not beautiful, but that's okay. That's what we do in the next step. What we have now is clearly that table. We have the rows 0 through 10. And we have all the elements, and it's formatted kind of weird because if it was on 2 different lines, it uses a dash, and then it slams the periodic number, the symbol, and the atomic weight all together with the name. But again, that's the next chunk of this. What we've done now is we've gotten that table off the internet into our program. And so what I want to do is I want to put that data into a CSV so that I don't need to be connected to the internet to run my program. So what we'll do is we'll say target data dot, and then this is a function of CSV of pandas. Once you have a data set, you can use this dot to CSV. And then call it whatever you want here. I'm going to call it periodic data.csv. But basically, this is built in, and it's going to make that file. So if it doesn't exist for you already, it will generate that CSV file when you run this. And then index equals false, and encoding equals and UTF-8. These are just some very standard settings that I like to use every time. I think you could actually run it without index equals false and encoding UTF-8. I don't think you need those, but I always put them in because I just learned that as standard. Okay, so now we're going to run this. Go ahead and run get data. Bang. And it still gives us the same thing down here, which is fine. But now if we have if you have a folder, and I don't know how to make that particular tree larger in the window, but hopefully you can see there's a periodic data.csv. And if I open that in Excel, so I'm going to open in the Explorer so that I don't open it within PyCharm, which looks kind of weird. So I'm going to open it in Excel. And what you'll see is it's not maybe the most beautiful periodic table you've ever seen, and they do this thing where they sub the dashes for like an A with a arrow over it and then the dash. So there's some weird formatting going on, but hopefully you can see the information that we need is in here. It's just a little bit jumbled, and so the next segment of this project is going to be cleaning up that data and making it usable. So for now, I'm going to say that is good on the pandas portion. We have taken a table of data from the internet and we have stored it in a CSV. So that is all I'm going to do for the get data portion of this project. The next thing is going to be cleaning up that CSV. Okay, so we are moving on to the cleaning the CSV portion of this project. And what we're going to do for this is we're just going to import the CSV module. So import CSV, run pip and install CSV if you need it. But basically, we're going to put all the functionality of this project into something we'll just call scrub the CSV, because I might be giving the end game away here, but I want to call this function from the third portion of this project. So when we do the visual element of our interactive periodic table, I want to be able to call this scrub the CSV function from inside there. And so we're going to put this whole thing in a function, and that way at the end, to make sure this is working, all we're going to have to do is just call that function down here at the end. Okay, so this is sort of similar to putting like an if name equals underscore underscore main underscore underscore, just making it so that this .py file can almost be used like a module or a library. Okay, and so that means we're going to have some variable of our cleaned data that'll basically be a list of elements in the format that we want them to be, okay? And so the first thing I think we should do, it'll kind of tell us what we need to do with the rest of the project, is we want to open that file. And so what I'll say is with open, and then the file name, which is just periodicdata.csv. And if you have it stored somewhere that is not just in your PyCharm project or Python project folder, you need to use the whole file path there. But mine is in the same folder. And then what I'm going to do is just say new line equals space, like that. So again, that's kind of standard, but you could make any new line indicator right there. And I'm going to call that file CSV file. So I'm just saying as CSV file. And then you want to define a reader when you're using CSV, the CSV module. And so we'll do CSV.reader of the CSV file. And we're going to put that in this variable that we call reader. Okay, and so what I'm going to do now is I'm going to actually print the row. So I'm going to show, so we have the reader, and then what I want to say is for row in reader. Okay, so basically for every row that we just read out of the CSV file, I want to see what I'm reading. And let's see. Yeah, let's just start here and let's run it and see what happens. So run clean the CSV. Okay, and you're going to see I get those elements kind of like we saw in the CSV when I just had it open. And you can see there's some extra stuff in here. There's like a header title, and then there's also a second row which says the group names. And then you can start seeing the actual elements here with hydrogen, and you'll see we get these special characters for dashes. It's the A with the caret, and then \XAD. That's dash. And then you can see between the symbol and the weight, we get a special character as well. So we're going to clean that up. That's the purpose of this section of the project. And so what we'll do is we'll actually skip row 1 and 2 since those are headers, and I just want a list of the elements. You could find a way to incorporate the headers if you want. But so basically what we'll do is we'll make a count variable. So count equals 0. And what I'm going to do is I'm going to say for row and reader, if the count is greater than 1, then I'm going to clean up the data. So what I'll do is I'll say for I in range length of my row. So for every element in that list that is each row, what I'm going to say is I want that element to be cleaned, okay? And what I'm going to do is I'm going to take my cleaned data list, which again is going to be my list of all the finished elements, and I'm going to do dot append, And then I need to just sort of hand wave at you for a second and say, we're going to make a function that is going to clean the data. So that's what I'm going to say. And the things that we need to tell this function are just going to be whatever our element is. So row at index I, and then whatever the index is, and whatever the count currently is. So basically what this is telling me what row and what column it is, which is going to be really important when we put them visually on the screen. But so basically we need to make this clean data function. And then the only other thing I'm going to say here is if count greater than 1, well, I still need count plus equals 1 every time. So put this outside of the level of indentation of your if statement so that it does happen even when count is less than 1. That's how we're going to skip over the first 2 rows. And then what I'm going to do is just say that, because remember, I'm in this whole scrub the CSV function. What we want to do is we want to just return cleaned data. So just so that I don't forget, when we call this function, the most important thing is that we get the cleaned data, the elements list back. Okay. So let's come up below scrub the CSV, but before with open, and let's define that clean data function. Okay. And if you remember, what we're passing in here is each individual element, and then we are also passing in the column number, which is index I, and then we're also passing in the row number, which is actually whatever row we are currently on. Okay? And now what I'm going to do is I'm going to make an index equals 0, and then the 4 things we're getting out of here are the element's name, the element's number, the element's symbol, and the element's weight, right? Those are the 4 things we're getting out of this periodic table, okay? Or out of each thing that we pass into the clean data list. And so that is also the order that they go in, is name, number, symbol, weight. And we know that because we ran this and we saw in our console window that or I guess it's gone now, but we saw in the console window when we ran it that we get those 4 things in that order. And so actually, let me just put in here pass. Okay. Now let's see if I can run that again so that I can show what I'm talking about. Yeah. Okay. So we get these, right? We have magnesium 12 Mg 24.305. Those are the 4 things we want, but we need to get the dashes out of here, and we need to get these separators between the symbol and the weight out of here as well. And the baby's still good. Just checked. Okay, so now let's go ahead and take a look at how to do that. So this is my solution. I think it's going to work pretty well, but if you feel that this is not super elegant, just let me know, and that's fine. But what I propose we do is we just start at the beginning of the string that we're passing in here, and actually that should be 1 in. What we're going to do is we're going to start at the string that we're passing in here, and we're just going to go 1 at a time. So we're going to say while the index, which is going to keep track of where in that string we are, is less than the length of my element, and the element at index is not in a list of numbers. Okay, so what we need to do is we need to make a list of numbers. But what's really cool about this is if you look at what tells us that the name is done being received, is that we've gotten to the atomic number. And it would be a real pain in the butt to make a list of all characters, but it is not difficult to make a list of all numbers. Okay, we have 0, 1, 2, 3, 4, 5, 6. If we remember our kindergarten, we'll remember that 8 comes after that, and then 9. And of course, we want to include 0. And actually, just a little bit of foreshadowing, it's going to be important to have the brackets in here because there's a few elements later on that are actually just like theoretical weights because we don't have a stable isotope. So to sort of include those, we're going to include the square brackets. But basically, that is a list of numbers that separate the verbal, or no, what do I want to say? That separate the strings from the numbers in this. So basically, while my index is less than the end, so this is just me making sure I don't do an index out of range, and the element that I'm currently checking is not in the numbers list, what I can say is name plus equals element at my index, okay? And then I can say index plus equals 1. And if I had a single row, element like boron, and if they were all single rows, this would be all I'd have to do to get the name for every variable. But I have to add an if else in here because we have if element at the index is equal to this special character, right? So if the element that I'm checking, and I'm just going to copy it out of down here because I don't know the ASCII code for this character, but I'm going to copy it. And basically, if my element at the index I'm checking is this special character that tells me it's a dash, then I don't want to add it, right? Then what I want to do then is just skip over the special characters. So I'm going to do index plus equals 2 and then an else, okay? And the reason it's plus equals 2 is that these are actually special characters. So if I copy this whole thing in here, I think I need to put in a string so you guys can see it. But yeah, XAD, \XAD is basically dash, okay? So it's like new line dash, I think. But I don't want to skip 5 characters, even though there's 5 keystrokes here. I only want to skip 2 indexes when I get here. And this is going to let me skip over the dash because I don't want the dash for my visual part of the project. So anyways, if I get to the dash, the line break, I'm going to skip over that. Otherwise, I'm going to keep adding to the name. And this is going to give me every element's name for my entire list, okay? And now we get to do a really easy next step, which is going to be another while loop, which is going to be while index less than length of element. And the thing is, if our function is working properly, this first part does not matter until we get to the atomic weight, because that's the only one that's going to butt up against the end of our string. But I like to guard myself, and I like to kind of handle potential issues down the line. So what we'll do is we'll say, all right, well now while the index is less than the length of element and the element at index is in this time, is in the numbers list. So that means that I am looking at a number. Then now we've just finished getting the element's name. So now what I'm going to do is I'm going to say number plus equal element at index. And we can't just say take 1 or take 2 or take 5 characters because we don't know if it'll be a single digit element, a double digit element, or a triple digit element. But in any case, we'll keep moving through with our indexer variable. Okay? And now what we're going to do is we'll do the same thing. Essentially, I'm going to copy this whole thing that we did for the name, and we're going to use a very similar while loop for the symbol. I think that's what we're doing now. Yeah, symbol. Okay, so while the index is less than the total element and the index is equal to, but now it's a lowercase a. So again, I'm going to come into my string and I'm going to copy the lowercase a. And it's going to be this that differentiates between the symbol and the weight. Okay, and so now let's copy that whole thing so you guys can see what it looks like in a string. It is 3 characters. So we will say if that is the case, we'll do index plus equals 3. And then otherwise, we will do just symbol, not name, plus equals element at index, and then move on through the index. So I hope I haven't lost you yet. We're taking these super long strings here, and we are saying, all right, I'm making an index variable. Whoop, I thought I copied it. There we go. What we're saying, to be clear, is I'm going to take an indexer variable and I'm going to go 1 character at a time through this string. And if it's not a number and it's not this special dash character, add it to the string that tells me the name of the element. Then once I get to a number, add it to a string that tells me the atomic number of the element. Then I'm going to get to a letter, and it's going to add it to the symbol of the element. Then I'm going to skip over these special symbols, and the last thing we're going to do is we're going to add it to the weight of the element. Okay, so that is the last while loop we're going to put in here. And these while loops are really nice because they're going to handle the variance between strings, and they're going to say we don't need to know how long the string is when we get started, because the while loop will just go until our end cases are met. Oops. So what we're going to do now, what tells us if we should add something to the weight or not, is going to actually be if the element index is in the numbers list. Okay, and this might seem silly, but it's going to help me not get unnecessary extra characters, and it's just smart to do a little bit of defensive programming in general. Okay, so I don't know why my indentation looks so weird. Bang. Okay, so that should be all we need to do, but we don't want this index plus equals 1 under that if statement. We want it to go no matter what. Okay, so now instead of pass, we need to return everything about an element because we are appending it to a list of our cleaned data. So we will return the name, the number, the symbol, the weight, the column number, and the row number in a list. And this is going to be one item in a list. Okay, so that is what our cleaned data variable is going to be. So I'm going to collapse the clean data function for a second, and we're going to come back into the outer world so we don't forget what we're looking at here. For every element, which is what this for loop that we set up is doing, for every element, I'm going to pass in that jumbled string we talked about, and we're going to clean it using that function we just made, and we're going to add it to our cleaned data list, which is what we return out of this whole function, okay? So it might seem a little chaotic, and actually one thing I want to do in here, just so I don't have to pass it in, is I'm going to say global cleaned data. Actually, I don't need to. All right, no, I'm not. I don't know why I said I was going to. That should work. Now, let's go ahead and take a look. I'd like to, I think, return the cleaned data from this function, but I also want to print the cleaned data, okay? So when I boot this up and run it, actually it can be a little difficult to conceptualize, but the only rung of code that gets called immediately when I boot this up is going to be this scrub the CSV, which is calling this function where everything we just wrote lives, okay? So let's boot this up. Run clean CSV, list object is not callable. All right, let's take a look. Return clean data with parentheses. Yeah, okay. Now let's try that. It should not have parentheses at the end. Bang. Okay. Look how freaking cool this list is now. All right. These elements were all just split over multiple rows. And the only issue that I'm seeing right now is we don't have decimal points in the atomic weights. So I think this is really easily solvable. We just need to add a period to our numbers list. And then that should now give us decimal points in our atomic weights. So let's check that out. All right, and that looks a lot better. And then the only other thing I'm seeing is we have a lot of empty entries because in a periodic table, it's not a perfect rectangle. So there are a lot of stuff where there's no weight to be entered. There's no information to add. So that's also super easy to fix. What we'll do is we'll come down where we say for row and reader, and we'll say for I in range length of row, we'll just add a condition here that's basically if the length of the string in that element, in that index element that we are passing, if the length of it is greater than 1 character, and that just means it's not an empty string, right? Then we'll say, okay, that's when I call cleaned data. So now if I run it, and I'm going to comment out print row real quick because that is just adding too much, I think, to the display window. So now this is our cleaned data. Okay, look how good it looks. This is just a list of all of the elements and then their atomic number and then their symbol and their atomic weight. And maybe it's just because I think this is really fun because I'm a nerd, but we got this from a Wikipedia table on the internet. We didn't have to manually type in all of the information. And the only thing I'm seeing in this list that is not what we want is that we have this period 1 as a first entry. So we're going to come, and this is a little bit of manual cleanup, but we're going to come in and we're going to say, all right, if it's greater than 1 and it's not equal to period 1, then I want to add it because that is the only entry that was not an element that still made all of my other things work. And so now you'll see this is so cool. We have the list of all of the elements. That is going to do it for the cleaning the CSV. And so the last part is going to be making that interactive graphical user interface that we talked about. I'm going to comment out print the clean data because we're going to pull this information into our GUI, our graphical user interface, and we don't need to print that onto the terminal every time we run it. So let's take a look at how to make a display that you can interact with in Pygame. Okay, so as we jump into this draw the table and interact with the table function, I want to remind everyone of what the end goal is going to be. It's going to be a pretty standard looking periodic table that has lanthanides and actinides in the lower side, which is a pretty standard way of looking at a periodic table. On the little icons on the screen, it'll just show the atomic number and then the abbreviation, so the symbol. And then when you hover over it, I want the full name, the atomic weight, as well as the group that it's in to appear in that window in the top as we scroll over it. So that's what'll make it interactive. And then we're going to group it by family. So we're going to group them by transition metals, alkali metals, earth metals, just using different color schemes. Okay, so that is the end goal here, and that's what we'll be taking a look at doing together. Okay, so this is a really fun part of it. It's where we get to take this data that we've scrubbed from the internet and actually use it and do something with it. And so the first thing to do is import Pygame, do pip install Pygame if you need it. And then what I want to do is I want to say from my clean_csv.py, which is this one that we just worked on that cleans up that data. I want to say from clean CSV, I want to import the function that I called scrub the CSV, and I'm just going to say as scrub, okay? And so what I want to do is I want to say, all right, the data set that I'm looking for my drawing is going to be equal to just running scrub, okay? So I know what scrub returns because I just made it. It's going to give me the data set of all of the elements, and each element in order of name, symbol, what was it? It was name, atomic number, symbol, and then weight, and then column, and then row. Okay, so that is what my data set is going to be. It's going to be a list of lists of that information. And now we need to set up Pygame stuff. So I'm actually going to come up here by my imports and do pygame.init like that. And then I'm going to say FPS equals 60, width equals 800, height equals 600, and then set up the screen, which is going to be equal to pygame.display.set mode, and then the width, and then height, bang, like that. Very cool. And then we will say pygame.display. This is an optional step, but it's nice to just set the caption to periodic table, just like that. And then we will say, let's establish a timer to run at that frame rate. So that'll be pygame.time.clock with a capital C, just like that. And then I'm going to make a font because we need a font, but we're going to come back later and we're going to make some bigger fonts as well. So for now, I'm just going to use freesansbold.ttf because I believe with Python installs, that is the default font that everyone should have. But if you don't have it, import a TTF file, no problem. Okay, now I'm going to define a couple things because a periodic table has a few different things that we need to use to define cell sizes. And so the thing is, the columns that we want to use are going to be, I think, 18. Yeah, so calls is going to be 18. And then the rows is going to be 10. And these aren't numbers you have to do manually. You could look at whatever the largest column and row number in your list is, but I looked at our list of data. I looked at the CSV. We have 18 columns and we have 10 rows, okay? And so the reason that's important is we're going to do cell width equal to the width of the screen divided by the columns, okay? And then cell height is going to equal the height of the screen divided by rows, okay? It's just that simple. And then you kind of saw when I was interacting with it that we need this variable to check if something is actively highlighted or not. So I will make this variable highlight and it'll be initially false. Now there are two things that might seem a little bit painful, but we kind of have to do it manually if you want to have control over what colors the different groups are. I'm going to copy in a list I have of the various groups and what color I want them to display as. And the good news is, if you want to change the colors on your project, all you have to do is come in here and either give them a different color, or if you just want slightly different variation, you can make these RGB values instead. So this is basically a list that I'm going to use in the drawing of the screen that says each group and what color I want it to display on the screen as. Okay, so I have just standard Pygame colors in here, but you could replace the words light blue, yellow, orange, red, blue. You could replace those with RGB values if you want to mess around with the visuals of your project, okay? But this is the list that's going to control the visual look of it. And then also, I did this because some people feel that certain elements fall into different groups. I don't know why, but basically in particular, like some people feel that polonium should be one of the, I think it's transition metals, but there's a couple variations on this you can do. I just went ahead and in the same order as my colors, so in alkali metals, metalloids, actinides, alkaline earth metals, reactive metals, I defined the groups in terms of numbers. So if you are following along line by line, I recommend you pause on the colors list, and I recommend that you pause on the groups list, and you can copy these down if you want. Of course, you can go to the GitHub link in the description of this video and just get this list as well. Like the transition metals, there's so many of them, and it's so easy to make a mistake. But we are going to reference each element's atomic number against this groups list, get the index, and figure out what color and what group it's in using this list that says by atomic number what each group should have. Okay, so these two lists are really important for the visual aspect of our project, and they're going to be really important. And if you are unhappy with the fact that it's a somewhat manual step, you can go back to Pandas and you can find a way to scrape the internet for a table that tells you each group. This is not a deep dive into Pandas, so I'm not going to do that. But those are going to be really important, and when you see them in our project, I want you to know where they're coming from. Okay, so now let's set up the main game loop. We're going to make this run equals true, and I'm calling it main game loop. It's not really a game, but for all intents and purposes, we are setting this up like a Pygame game because that is sort of the same steps we need to follow. All right, so screen.fill with the color black, and then timer.tick at our frame rate. And you can fill it with any color you want. And then what we're going to do is we're going to get back all of the active like element rectangles from this function draw the screen, and we're going to pass our data set into draw screen. Okay, and for now I'm just going to make that function define draw screen. We are passing in the data and we are returning element list. Okay, so just so we don't forget what we promised to return, element list. There we go. We are passing in that information, but for now I'm going to wave my hand at that and say we are going to come back to that, okay? And now I'm just going to come right below that and say for event in pygame.event.get, and this is a step we always have to do when we make that while run because we start out with an infinite while loop and you have to have some way of getting out of it. And so we'll say if event.type is equal to pygame.quit, all caps like that, then we will set run equal to false. And then the last thing we do is we just come out of that list and we say pygame.display.flip. And then outside of that, outside of our while loop, we just say pygame.quit. Okay, so this is boilerplate setting up a Pygame game, a Pygame graphical user interface. Nothing super unique yet, but it's time to flesh out that draw screen data set. So if we boot this up, it's really uninspiring right now. But the fact that we don't get any errors is actually a really good thing because we're calling that scrub the CSV file. We are creating a window. And so we have this really good platform to build the rest of it off of. Okay, so that is all we need to do to set it up. Now let's actually take a look at this draw screen data function. And it's about 30-ish lines of code, but mostly it's really cool and it's really intuitive, okay? So let's go ahead and say we start with this empty element list, and then for I in range length of the list of data that I was given, all right? So that is saying cycling through every element. And just remember, the element is going to be equal to data at I. And so this is just to make it a little bit simpler so that every time I don't have to say data I and then another index to reference things. And remember, the order is name, number, symbol, name, number, symbol, weight, column, and then row. Okay, that is the information every element has. All right, and now what I will say is for each element, now we'll cycle through the groups, and we'll say for Q in range length of groups, we'll just go ahead and say if the integer, because remember they're all strings, of element 1, so that is the atomic number of each element, is in groups Q, then we want the color to be equal to colors at Q, but then 1. So what we just did here is we went through and we said for all the groups that I have, if my atomic number is in that group, then I want to use that index, which is Q, to get the color that I'm supposed to draw this element at. So this is kind of a creative way of using our list to check what group it ought to be in and then get the color that it should be in doing that. There are a few different ways to do this. You could use dictionaries, you could use lists. There's a whole bunch of different ways that you could do it. I liked this way. If you don't, do it another way, and that's cool. Okay, so now let's go ahead and say if the element 4, which again, name, number, symbol, weight, column. Yeah. So if the column that I'm in is one of the first columns, if it's less than 3, then I want my X position to be equal to my column number, so element at 4 minus 1, because the first one is going to be 1, but I actually want it all the way up against the left side of the screen, so that will be 0. So minus 1 times the cell width that we already determined, but then else I will say X position minus 2. And the reason we're doing that is that the separator for lanthanides and actinides originally had an entire blank row in the Wikipedia table. So if we go back to it, you can kind of see this effect. They made this an entire column in their table to break it up, and I don't want to do it exactly that way. You'll see what I do want to do. But I actually want to do this slightly differently. So what I'm going to do is I'm going to say for those first couple, we want it to be minus 1. And then for the rest, we'll do minus 2. Okay? And then we can define the Y position. So Y pause is equal to, and then element at 5, which is the row, which tells us the vertical height, and then minus 2. Because remember, we knocked 2 rows off of that table. But so the row number that we saved starts at 2, but we want to start at 0. And then times cell height, okay? So that is how we're going to get the X position and then the Y position. And then we'll make this box, which is going to refer to the object that can become highlighted, that you can select. And that will be pygame.draw.rect. Let me scroll it up here a little bit for you guys. So pygame.draw.rect, and these take a few arguments. So we draw them onto the screen, and then we draw them at whatever color we just defined from our lookup of the group. And then we're going to put the X position and the Y position as, oops, these need to be inside square brackets. There we go. So a rectangle takes X position, Y position, width, and height. And the width and height are just going to be cell width minus 4 and cell height minus 4, because I think they look good with a little bit of a border. I'll move this down to a new row so it's easier to see. So I don't want it to be the full cell height and cell width. I think it starts to look a little squished. Plus, this way we can put a cool looking border around all of them. Okay, so we'll do, now this one doesn't need to get saved in a variable because it's just a border. But for every single element, I'm going to put a silver, sorry, I kind of yelled in the mic there. I'm going to put a silver border around it in the exact same spot, just scooted a little bit back to the left, xpos -2, but then the full width and height, and then I'm just going to make it a hollow rectangle with border width 2. So this is basically a width 2 frame around every box, okay? And before we do too much goofy like adding onto this, let's see what just that gets us, okay? So what you'll see is a pretty cool looking table already that you can see is grouped by color and element already, and it looks super good. In my opinion, it looks super good. There's a few manual things we're going to do to get this column the way we want it. And then, of course, I want to sort of draw an indicator that this entire lanthanides and actinide table gets stuffed up into that space. So we'll do that in just a second. But for now, why don't we do the next really satisfying thing, which is get the text and the symbol and the atomic number drawn onto every box on the screen. So let's do screen.blit. And then I'm going to use that font we defined, font.render. And the text is just going to be element item 1 true. And so that will be the atomic number. And we're saying true is anti-alias. It just smooths it out. And then we'll make the text black. And then the position for it is going to be our already defined X position plus 5. And this is just to get it off of the left edge. And same thing, Y position plus 5 to get it off the top. Okay? And so just doing that, if we boot it up, you should see we get all of the atomic numbers, which looks really cool. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. There we go. Very cool. The atomic numbers are on. So let's take that entire row, and we're just going to modify it slightly to get the symbols on as well. So element 2. And we will say xpos plus 5. So we'll keep the same X position, but we'll do ypos plus 20, and we'll scoot it down the screen. And then all I want to do is I want to take my element list and I want to dot append and I want to add a couple things. I want to add the box, so the selectable item, but then I also want to add in whatever the index was as well as whatever the color we found was, because we're going to use those things in the highlighted top section of the screen. So I don't just want to say the object, I also want to give it I and the color, which will be useful later. But for now, that should be everything we need to just get a list of all of the elements with their list.append takes exactly one argument. That is true. You need to put this whole thing into a tuple. Oh, Pete, you slay me. Here we go. All right. All right, so there we go. We have the atomic number and the elements, and it's looking really cool. I'm not super thrilled with 71 and 103 being right there, and so we do have to do a slightly manual process to put them where I want them to be, but it's not that hard. It's just a kind of a silly bit of manual code in what's been a pretty cool automated function so far. But what we'll do is we'll say, okay, if element 4, which is my column, is equal to 4, which is that column that those two that I want to move are in, and element 5, which is the row, is in either 7 or 8. Okay, so this is just a quick little list of the two objects that I want to move. Then I'm just going to overwrite xpos and ypos. And now I'm going to say xpos is going to be equal to element 4 plus 12, and then times cell width. And so this needs to be in parentheses because of order of operations. And so I'm just saying I'm going to move them 12 over and a couple down if it's those two variables. So I'm just, or those two elements. So I'm just taking the two that I don't love the position of, and I'm scooting them down a few, over and down. All right. And so this should just scoot those two over quite a few. You'll see this was originally a -1 or -2. It is now a +12. So we're moving it like 13 or 14 columns to the right. And this was originally a -2. It's now a +1. So we're scooting it down 3 and over 13. But these 3 lines of code should put those last two lanthanides and actinides right where we want them. Bang. Okay. How cool does that look? Now we have this kind of silly cutout in here. And obviously in this row, it goes from 56 to 72 and 88 to 104. So it could be nice to just do some quick indicators explaining sort of what's going on there. It's not necessarily a functional ad, but we'll say lengths and x explainers. And it's just going to be a line and two rectangles. So bear with me really quick. We're going to do pygame.draw.rect, put on the screen, and we're going to make it white. And this is just going to be cell width times 2, cell height times 5. So this is at the hole. It's going to be 1 cell width wide, and then it's going to be 2 cell widths, 2 cell heights tall. So let me put you on a new row. 2 times cell height. And then we're going to just make this a border 3, so a hollow rectangle, but a rounded rectangle with a radius of 5 for the rounding on the edges. I know that went off to the side a little bit there. That's just because I give you guys big text. Okay, so I'm going to copy that. It's going to give us a little white rectangle in the... Oh boy, what did I do? I don't know what just happened. Okay, we're fine. I'm going to now put a white rectangle around the objects down on the bottom. And so to do that, I'm going to keep this cell width times 2 as the starting X position, but we need to scoot it down to cell height times 8. And then it's going to be cell width times 15. It's going to wrap around all of those lanthanides and actinides. And then it's going to be 2 times the cell height. And then I will keep 3 and 5. And so hopefully when we boot this up, we have 2 rectangles, and all we have to do, so we have a white rectangle in the hole and a white rectangle around these guys. And I think they'd both look a little better if they scooted to the left and up a little bit. So let's just do -3, -3, -3, and -3. So I'm just shifting them a little because they looked a little funny in the hole. And I think that looks way better. It really wraps around what we want. And now I'm just going to draw a line from the open rectangle to the, what am I trying to say? Come on, guys, help me out. I'm going to draw a line from the rectangle that's in the hole down to the rectangle around the lanthanides and actinides. All right, and so that'll be screen, white, and then all a line needs is 2 positions. So it'll be cell width times 2 and cell height times 6 as a start, times 6 as a starting position. And then the end position will be cell width times 2 and cell height times 9. Pretty cool. And we'll make it a line of thickness 3. Okay, so super easy, just defining a line with 2 points. If I run it now, I like everything about it, except I think it also needs to scoot to the left. So we'll do cell width times 2 -3. Hopefully that's all we got to do. Oh, they both points have to scoot to the left, or you're going to have a silly broken looking rectangle. All right. And there we go. Okay, that looks really, really cool to me. And the only remaining thing to do, and it's not that hard, is we want to get, when the mouse is over an element, we want to fill this top empty section in the middle with information about that element. And this is going to be super easy because we're already returning a list of all of the elements that we can check and see if we have highlighted already. So to do this, we're just going to make a new function that we'll call draw highlighted, and we'll check and use that highlight variable we defined up here. We'll check and see if something is highlighted. So let's come under the for event in pygame.event.get, but outside of it. And let's get mouse position, which is a variable that we will get using pygame.mouse.getPosition. Okay, so this is going to give us the X and Y position of our mouse. And every iteration, let's set highlight equal to false until we've proven that it's not false. So we'll say for E in range length of elements. I'm using E because it's a list of elements. We'll say if elements at E object 0. So that is the box. That is the pygame.rect, which has a built-in collide point checker. And so we're checking for every element to see if it's colliding with the mouse's current position. And if it is, then we're going to set highlight equal to true. And we're going to make this new variable info, and we're going to set it equal to elements at E, but this time just object 1. So that's where we passed in the index and the color, and we're going to use that to define the rest of the information that we need. We don't need the box object, so we'll just put that in this info variable. And now let's come up here under our elements, and let's just say if something is highlighted, why don't we draw the highlight and we'll pass in info, okay? And then we'll say that's it. Let's say that's it. All right. Now define draw highlight, which is pretty cool. And we will pass in that stuff we need. And I'm just calling it stuff because my brain's a little scattered. I haven't slept through the night in a few weeks. But let's take a look at what we're going to draw from that stuff. So first off, the classification, which I'll just call class. Nope, I'm going to have to say more than class. We'll say class if. We'll say classification. There we go, just to get rid of any unclear stuff. And then we'll say info. All of the info we need is going to be equal to, we'll say information, is going to be equal to our data set that we pulled in from the scrub at index stuff, okay, item 0. So that is the I variable. So we're basically saying the I that we got from draw screen is all the information we need in our draw highlight, okay? So it's a lot simpler than combing through the whole list. And then what we'll do is we'll say for I in range, length of colors. Yeah. Okay. For I in range length of colors. So this might seem a little bit backwards because we already looked its classification up once. But we'll say if the color that I'm passing in here, I, is equal to the color that it's being drawn at, then that means the classification is equal to colors at I0. So just really quickly to talk about this because it might seem a little confusing. There might be better ways to do it. We are figuring out what classification it is, meaning what group it is, by figuring out what color we drew the original rectangle as and grabbing whatever the descriptor of that color is. So that's what's going on here. I kind of liked doing it this way. I felt like a total hacker, but there may be better ways to do it. All right, so stuff that's going to be the same for every highlight will be a few rectangles. Pygame.draw.rect. We'll put the first one on the screen as kind of a light gray, just surface to work with. And we'll put it at starting position cell width times 3, cell height times a half. And then cell width times 8 will be how wide it is, and cell height times 2 will be how tall it is, okay? And then I do want this to be a solid rectangle but rounded. So I'm going to give it 0, meaning I want to be filled solid, but then 5, meaning I want rounded corners, okay? And I'm going to copy that whole rectangle just to make a couple sort of style improvements to the overall shape. I will now say just inside of that, let's go ahead and make a black border, cell width times 3, cell height times 1.5, and then the same width but down a little bit, so cell height times 0.8. And this is where I'm going to draw the group, the grouping of the object. So when I have a object selected, I want to draw actinides, lanthanides, alkali earth metals, transition metals, whatever it is. And I'm going to put that on a black background. I thought it looked cool. If you don't sue me, whatever. Okay, so now let's just do a quick border, and we'll say, instead of light gray, this will be dark gray. I will keep cell width times 3 and 0.5 and times 8 and times 2, just like that first rectangle. But instead of being solid, this will just be a nice thick border of 8 pixels around the whole outside. Okay? And so if I run this, what you'll see is, all right, when I'm over an element, I have like a light gray top section, a black bottom section, and then a dark gray outlined rectangle. And it goes away when nothing's highlighted. So it's working properly. I'm just not doing anything interesting with it yet because we're not putting information on there. But we've set up what we are doing for every element. Okay, so let's put some stuff on there. Let's do screen.blit. And let's do, remember I said we were going to put a couple more fonts in here. Let's make a big and a medium-sized font. So I'm just going to copy font here. I'm going to make two more. I'm going to make one mid-size font, and then I'm going to make one a big font. And they'll all be the same TTF file, but they'll be size 28 and size 36. And then we will come back down, and we need to put 4 things on there basically, right? We want to say the atomic number, the symbol, the name of it, and then the grouping. Oh, and the atomic weight. So that's 5 things. Okay, no problem. Now let's go ahead and just do screen.blit and big font dot render. And this one will be info 1, which I believe is the number, and then plus a dash, and then we will say plus info 2, which is the symbol, and that'll be the first thing we put on the screen, and we will say true, and we will say that text can just be black, and then the position that we put it on is going to be at cell width times 6. Am I getting twisted? Yes, I am. Okay, it's going to be at cell width times 3 plus, why is this so hard for me now? Plus 5, and then cell height times 0.5 plus 10. Okay, so let's go ahead and see. That should just give us in black tuple out of range. Interesting. What did I do? Oh, it's because I said info, but I think I called it information. Nice. Nice. Cool. You don't have to use super long variable names if you don't want to. I sometimes try to be descriptive when I am doing tutorials, but that can make it a little hard to keep track of. Okay, so what's cool is you can see exactly as much information as you already had, but in the highlighted window in bigger text. So that's a good start, but again, not super interesting yet. But that is okay, because every great journey starts with a single step. I don't know who said that, but shouts out to whoever said that. I'm sure it's a famous quote. Okay, mid font dot render. And now let's go ahead and put the full name of the element on. And it has to be mid font because that's quite a few more pieces of text. And that'll just be information 0, nothing else getting added to it. True and black. And we want to move this far enough to the right that it'll always be past the symbol and the number and the dash that we just defined. So I did a little bit of guess and check here ahead of time, and I just moved it to cell width times 6 plus 10, and that was pretty good for getting the whole name on the screen. Now, the next thing I want to put on the screen is going to be information 3, the atomic weight. And I'm going to use the same X position as the name. All we're going to do is move it down a little bit. So instead of 0.5 plus 10, it's going to be 0.9 plus 10, which, again, a little bit guess and check, but that wound up in a really cool spot underneath the name. Now we're going to do one more mid-font thing, and the information we're going to use here is going to be the classification, and it will be true, and instead of being black, it will be the color that we passed in from before. So whatever we passed in stuff 1, and then we'll put that at cell width times 3 plus 10, and then cell height 1.5 plus 10. So this will be squarely in that black rectangle that we defined. Let's go ahead and run that. And now, okay, you can see the full element name, its atomic weight, what group it's in, as well as the color changes for what group it's in. So I think that all just looks very good. It's super interactive. It's really fun. I have one more rectangle that it looks like I drew. Oh, yeah, this is cool. All right, we're pretty much done. But one thing I did do also, I took this dark gray rectangle, and it looks like, Control C, bang, bang, and there we go. It looks like I did this rectangle again in my original build, and rather than border 5, I made it border 8, and rather than dark gray, I made it the color of that family's grouping. So let's see, what did I chop something in half? Why is this here? Screen.blit big font. Oh, it's just because indentation got messed up. That should do it. Okay, so I just made also a rectangle. I copied the dark gray rectangle. I made it 5 instead of border 8. And then I made it the color of that family's group. And so that, yeah, cool. Okay, so that gives us this like neon green for post-transition metals, alkali earth metals, alkali metals, reactive nonmetals, noble gases, bang. Okay, I think this is really, really cool. I had a ton of fun making this project. I was not sure the format to put it in. This 3-chapter thing kind of seemed to work. Obviously, all of the code, all of the assets are in the GitHub link in the description of this video. If you enjoyed it, please consider leaving a like on the video. Subscribe to the channel. Don't forget to let me know what you'd like to see on the channel next time. Thank you so much for watching. See you next time. Bye.